Welcome to The Explainer. Today, we're basically becoming cellular detectives. We're going to grab our virtual microscopes and break down a really fundamental skill in medicine, how to look at a peripheral blood smear and figure out the story it's telling us.
So, here's what we've got on tap. First, we'll talk about why this old-school skill is still a huge deal. Then, I'll walk you through a step-by-step way to look at a smear. After that, we're diving deep into the clues hiding in all the cells, red, white, and platelets. And finally, we'll tie it all together and see how this helps with an actual diagnosis. All right, let's jump right in. First up, the indispensable smear. We're going to talk about why this technique is, seriously, more important than ever.
And you might be wondering, it's a totally fair question. We have all this amazing automated tech that spits out a full blood count in like minutes. So why on earth are we still looking at a drop of blood on a slide?
Well, here's the thing. The machines are great with the numbers. They give you the what, but the smear gives you the story, the how, and the why. A trained human eye can spot all these tiny, subtle, but absolutely critical changes in a cell's shape or size that a machine just can't see. It really gives you the whole narrative behind the numbers.
Okay, so how do you do this like a pro? The secret is having a system. A repeatable, systematic way to look at every single smear. If you have a system, you're not going to miss the important stuff.
It's basically a three-step scan. You're going to start on low power, the 10x lens, just to get the lay of the land. Is this a good smear? Are the cells spread out okay? Then you'll bump it up to high power, 40x, to start getting a feel for what kinds of cells you're seeing. And finally, you switch to the 100x oil immersion lens. That's where the real detective work happens, where you get up close and personal with the individual cells.
Now, before you do any of that, you have to find the right spot on the slide. We call it the feathered edge. You can see it here. It's this perfect little sweet spot where the red cells are all lying flat in a single layer. They're just barely touching, not all piled up. This is absolutely critical because it's the only place you can really see their true shape.
Okay, now for the really cool part. Let's talk about red blood cells. These little guys, the erythrocytes, can tell you so much about what's happening inside a person's body, just from how they look. It's amazing.
Just look at the difference here. It's night and day, right? On the left, you've got your happy, healthy red blood cells. They're all about the same size, nice and round, with that little pale spot in the middle. But then look at the right. This is from a patient with iron deficiency anemia. See how the cells are way smaller? We call that microcytic, and they're so much paler, which we call hypochromic. The difference is just, wow.
Okay, quick vocabulary lesson. You're going to hear this word poikilocytosis. I know, it's a mouthful, but all it means is that the red blood cells have weird shapes. That's it. It's just a general umbrella term for all the funky shapes we're about to look at.
And speaking of weird shapes, this is probably the most famous one of them all. You're looking at sickle cells. That classic crescent shape is a dead giveaway for the genetic condition sickle cell disease. It's literally what happens when the hemoglobin inside goes haywire and warps the whole cell.
Here's another classic you'll see, the target cell. And you can see why it gets its name, right? It looks just like a bullseye. You've got that dot of hemoglobin sitting right in the middle of the pale zone. This happens when the cell membrane is kind of baggy, with too much surface area for the amount of stuff inside.
So, the moment you spot target cells, a little alarm should go off in your head. You should immediately start running through a mental checklist of possible causes. They're a big red flag for things like liver disease or certain hemoglobin problems like thalassemia.
Okay, let's look at two more really important shapes. On the left, check out these spherocytes. See how they don't have that pale center? They're just small, dense little balls. That's because they've lost some of their membrane. Now, on the right, you've got schistocytes. These are totally different. They're not whole cells at all. They're just busted up, fragmented pieces. This is a huge sign that the red cells are literally being shredded somewhere in the bloodstream.
This table is basically your cheat sheet. It's super useful. It connects the shake you see on the slide with why it's happening and what diseases you should be thinking about. Like, if you see teardrop cells, that points to something messing up the actual structure of the bone marrow, like in myelofibrosis. It's a great reference.
All right, so we've talked a lot about red cells. They're definitely the stars of the show. But you can't forget about the supporting cast. The white blood cells and the platelets, they have their own important stories to tell.
Take a look at this neutrophil, for example. The key is to look at its nucleus. Normally, it should have, 3 to 5 little lobes. But this guy, he's got 6 or more. We call that a hypersegmented neutrophil, and it's a huge clue from megaloblastic anemia. You see this? You should be thinking B12 or folate deficiency right away.
And it's not just about one cell.
You have to look at the whole white cell population. Are there tons of neutrophils? That might point to a bacterial infection. Seeing a bunch of weird-looking lymphocytes? Maybe it's a virus. And if you see really immature cells, what we call blasts, that's a major red flag for leukemia. The smear lets you see the body's immune system in real time.
And last but not least, the platelets. 2 simple things to check. Are there enough of them, and how big are they? When you start seeing these really big, giant platelets, like these here, it's a signal that the bone marrow is in panic mode. It's cranking them out super fast, usually because they're being destroyed somewhere else in the body. You see this a lot in conditions like immune thrombocytopenia.
Okay, let's bring it all home. In this last section, we're going to put all these puzzle pieces together and see how they lead to a diagnosis.
And this is maybe the most important takeaway of all. The smear gives you clues, not a final answer. Finding schistocytes is definitely concerning, but what does it mean? In a patient with a mechanical heart valve, it's expected. In a patient with kidney failure, it could mean something much more serious. Context is everything. The real power here is when you combine what you see under the microscope with the actual patient's story.
This quote really nails it. It's one of the few times in medicine you get to do this, to take what you learned from talking to the patient, from the exam, and then go look under a microscope and see the disease process with your own eyes. That connection is it's incredibly powerful.
So learning to read a blood smear isn't just about spotting weird-shaped cells. It's about learning a new language. You're learning to read the incredibly detailed and sometimes life-saving stories that our blood is trying to tell us. So the real question is, what story is your next smear going to tell you?